Hello everyone. In this video, I'll be discussing about Heapify operation. So this operation can be performed on both max heap as well as min heap. Okay. So the main function of this Heapify operation is that it restores the heap property. Okay. So in the heap, there will be a node which is violating the property of the heap. Okay, there will be a node which is violating the property of the heap. So if we carefully look at this heap or at this tree diagram, we find that root node is violating the min heap property. Okay, because the left subtree and the right subtree are min heap. Okay, left subtree and the right subtree are the min heap. But because of this 20, min heap property gets violated. Min heap property gets violated. So basically we are going to perform heapify operation on that node which one is violating the heap property. So there will be left subtree, there will be right subtree. These left and right subtree will be following the property of the heap, but because of this node, this whole heap is not following that property. Okay, so heapify generally performs on that node which is violating the property of the heap. Either it can be min heap or it can be max heap. So the node having left subtree and right subtree following the heap property, but that node is not following the property. Like because of this node, the whole heap is not following the property. So we need to perform heapify operation on this node in order to restore the property of the heap. So I have taken an example of min heap, and there is like this node is violating the min heap property. So we need to restore this heap to a min heap. Okay, so first what I will be doing is that I will be writing the index value, because we are representing this heap in the form of an array. So it will be simple to denote each node as its index value. 0 1 2 3 4, this is 5, and this one is 6. Okay, so we know that 20 is violating the property, so the index value is 0. I equals to 0, we will be performing heapify. So we are going to compare 20 with its left child value and its right child value. So 20 compared with left child value, the smaller is 10. Okay, and 10 if we compare it with the right child value, the smaller is 4. So basically we need to find the minimum of this node, the left child node, and the right child node. So the minimum value is 4. So the minimum value is 4, therefore we need to swap 20 with 4. Okay, we need to swap 20 with 4. Now 4 will come on the top. Over here there will be 10, 15, 18, 20, 5 and 6. Okay, now the disturbing node is 20. Okay, so the disturbing node is 20 because its left and right both are heap. A single node can be min heap or it can be max heap. Okay, so its left and right both are min heap. Because we are taking the example of min heap, therefore we can assume that its left child and right child both are min heaps. But due to this 20, the min heap property gets violated. So again we will be comparing 20 with 5 and 6. So the minimum value is 5. Okay, so the minimum value is 5. Now we will be swapping this 20 with 5. So this one is 0 1 2. So at index we need to perform heapify operation. So after performing heapify operation, the new tree is over here will be having 5. So 20 and 5 gets swapped. Okay, so now 20 will be over here, 6 will be over here, and 15, 18. So now, as this was not a heap because of the 20, using heapify operation over that node which is violating the heap property, we have moved from this heap to the new heap. Now this heap is a min heap. Okay, so heapify operation generally done on that node which is a disturbing node, which is violating the property. Its left and right subtree both are heap, but this node is a disturbing node. So we need to perform heapify over that node. So what we have seen is that find the disturbing node which is violating the property. Second, we need to compare that node with its left child and right child. Compare node with left child and right child. So on comparing, like initially, like this is 20, we have compared it with 10 and 4, and we got 4 as the smaller one, as the smallest one. So we will be swapping 20 and 4. Okay. Third, like on comparing, if left child is the smallest, if left child is smallest, swap node value with left child value. Or if right child is smallest, swap node value with right child value. In my previous video I have discussed about like what is heapify and in which node we need to perform heapify operations. So I have taken an example like 40, 10, 3, 15, 16, 4 and 5. It's a kind of a min heap where the root node is violating the property of min heap. Okay, so I need to perform a heapify on this root node. Okay, so we already know that in order to represent heap we need array data structure where like 40 is on the like is in the index value 0, then 10 will be in index value 1, this will be 2, 3, 4, 5 and 6. Okay, so in heapify, like first we need to identify like which node is violating the min heap property. So this node, the root node, is violating the min heap property. So the next step was to compare this 40 with left child and the right child. Okay, to compare this 40 with the left child and the right child, and we need to move in the direction where we are getting the smaller value. So in min heapify function, like this function is a min heapify function where we need to pass the index value which is violating the min heap property, or it can be max heap. Currently I'm taking an example of min heap, and we need to pass the size of the heap. So this is the variable, the smallest variable, which is storing the index of the node violating the min heap. Then we need to find the left child and right child. So already I've discussed the relation between the parent and the left child. So basically, if our root node, like this node, is violating the property, so we need to compare 40 with the left child value and the right child value. As we are dealing with the array, so in array the representation and the relation between the parent and the left child is done using this formula. So the left child index will be 1 and the right child index will be 2. Now we have used if statements to compare. Okay, so we need to check whether the array of smallest, so this smallest is the index, so array of smallest means 40. If 40 is greater than array of left child, so left child index is 1. So if 40 is greater than 10, smallest will be left child, so the smallest index will be 1. Okay, initially smallest was 0, but on comparing 40 with 10, now the smallest has changed its value from 0 to 1. Okay, now we need to compare 40 with the right child. So ARR of smallest. So ARR of smallest means 10. 10. Check whether 10 is greater than ARR of right child. So right child index is 2, which is 3. So 10 is greater than 3. So if 10 is greater than 3, our smallest changed from left child index to right child. So basically our smallest value will be 2. Now if we see this tree diagram, we find that on comparing 40, 10, 3, the the smallest value is 3. As the smallest value is 3, the index we need to store in the smallest variable. Okay, initially the smallest variable is storing the node which is violating the min heap property. Now after performing or after comparing it with left child and the right child, we will be storing the index of that node which is the smallest. Okay, on comparing 40, 10 and 3, we get to know that 3 is the smallest and the index is 2. So the smallest variable will be storing index 2. Okay, now in this, like, we need to check whether our uh, I, which was 0, has changed. Okay, so right now I not equals to smallest because I was initially 0 and it's not equals to smallest because smallest has changed from I to 2. Okay, so it means that there is a smallest value. Okay, so why we are performing this if operation? We are performing this if operation because initially we have taken smallest equals to I, but we get to know that in the left child and the right child there is a smallest value present as compared to that node value as compared to 40. So our I value got changed, like the smallest value got changed. Initially smallest was I, now the smallest has changed to 2. It means that there is a smallest value in the left child and the right child. So if this is the case, we need to swap 40 with 3. Okay, so on swapping 40 with 3, now 3 will be over here and 40 will come in this location, in this index value. Now again we will be recursively calling this min heapify for this node. Okay, for this node we will be calling min heapify. Now again we are going to compare 40 with 4 and 5. So we will be having this as the smallest one. Okay, so after performing this multiple if statement, the smallest value, the smallest index will be index 5. Okay, and initially the index was 2, like we were currently on this index 2, but after performing multiple if statement the smallest gets changed to 5. It means that left child and the right child is having the smallest value as compared to this disturbing node. Either it can be the left child holding the smallest value or it can be the right child holding the smallest value. If both are the smallest values, then we need to find the minimum one. So the minimum one is this one and its index is 5. So we are going to swap the value present in index 2 with index 5. So basically 4 will be over here and 40 will be over here. So the new heap will be like 3, 10, 2, 15, 16, 40 and 5. Okay, so initially the input array was 40, 10, 3, 15, 16, 4 and 5. On performing heapify on this disturbing node, our min heap property gets restored. Okay, so this is C++ code for min heapify operation. Now if I run this code, We will check for the output. Okay. So as an input, I'll be having the root value as a disturbing or as a violating node. So the input will be 40, 10, 3, 15, 16, 4 and 5. So after this, on performing min heapify on the root value, the output is 3, 10, 4, 15, 16, 40 and 5. So this is the output. So this is all about min heapify in C++.